Chapter 26, Example 1. Let's see how much we can learn about body fat and waist size from a regression model. Questions. What is the relationship between percent body fat and waist size in men? What model best predicts body fat from waist size? And how well does it do the job? So we're looking at a hypothesis test and a confidence interval to get an idea of how well it does the job. For regression, we're testing the hypothesis. Is there an association between the response and explanatory variables, or is there not one? So our null hypothesis will be that beta 1, the slope, equals 0, which means that there is no association between the variables. Our alternative will be that beta 1 does not equal 0, so there is some association. So we're saying there is a slope or there is not a slope. First, we have to look at a scatter plot. So we plot waist against body fat, and it looks pretty linear, no outliers. The scatter plot of waist size and body fat percentage is linear with no obvious outliers. That means our first condition. So now let's look at our residual plot. We have it here. The residual plot looks pretty spread out. The residual plot for the line of best fit shows no pattern or trend and has constant spread about the line. So that satisfies the second and third conditions. Now, to find a plot of the residuals, we're going to do a new data and statistics page. So the calculator automatically generates the residuals. It becomes a stat variable here. So we click on add variable and you find stat residual, and that will plot the residuals for us. Now we just say that we want it to be a histogram or a normal probability plot. Here we'll choose normal probability plot, and it looks pretty linear. The normal probability plot of the residuals is straight. The conditions are met. I will use a student's T model with 18 degrees of freedom for a regression slope t-test. Now we just have to generate this data. We can use the calculator for that. So we will go to Statistics, Stat Tests, and a linear regression t-test. Linear regression, we're always going to use a t-test. Same t-model we've been using. For our x variable, we picked the response variable, waist, and our explanatory variable is the y, which was body fat. Our alternative hypothesis is not equal to 0. So we click OK. There's all our statistics. We have to scroll a bit to see everything. Our t-score is 8.14374. We have a p-value of 1.89998 times 10 to the negative 7th, so that's very small. 18 degrees of freedom. The A is our y-intercept, negative 62.5573, and B is our slope, 2.22152. That's our B1. The SC slope is the standard error of the slope. That's important to know, especially for when we do the margin of error. We have our R squared and R there as well. We'll put most of these statistics in. So T equals 8.143. Our p-value is 1.8999 times 10 to the negative 7th. And we have 18 degrees of freedom. We'll go ahead and list our R squared and R. So R squared is 0.7865. So 78.65% of the variation in body fat percentage is accounted for by the waist size. R equals 0.887. Now we'll state our model. Body fat hat equals negative 62.56, which was our A from the computer printout, plus 2.22 times waist size. My p-value of 1.8999 times 10 to the negative 7th is very low, and I will reject the null hypothesis. There is evidence to suggest an association exists between waist size and body fat percentage. On average, as waist size increases, so does a person's body fat percentage. To see how well the model works at predicting, look at our R squared real quick, which was 0.7865. 79% of the variation in body fat percentage is accounted for by the waist size. Let's look at a confidence interval to help sum this up as well. We go to our calculator, we'll do statistics, confidence intervals, linear regression t-interval. We want to use its slope. For our x variable is still waist size, and our y is body fat. 95% interval, so we're good. We scroll up there and we can see our interval. It looks like the lower is 1.64841 and the upper is 2.79463. So we're ready to state our confidence interval. I am 95% confident that, on average, body fat percentage increases by 1.65 to 2.79% for every 1 inch increase in waist size.